Hello my dear friends, welcome to my YouTube channel. Myself, Dattu Patel, Assistant Professor from LJIT. Earlier lecture, we are already discussed about the infinity by infinity form and 0 into infinity form. Today's session, we are going to discuss about the infinity minus infinity form and exponential form, means 1 raised to infinite, infinite raised to 0 or 0 raised to 0 form. Firstly, let's start with infinite minus infinite form. Here, working rule of evaluating the limit in form of infinite minus infinite form. If limit extends to a f of x equal to infinite and limit extends to a g of x equal to infinite, then limit extends to a f of x minus g of x is called the indeterminate form of infinite minus infinite form. Then we have to convert into 0 by 0 or infinite by infinite form with the help of simplification or cross multiply, like as limit extends to a f of x minus g of x equal to limit extends to a 1 upon g of x minus 1 upon f of x divided by 1 upon f of x into g of x. Here, then and then we have to apply L'Hopital rule. Let's see the one example. Limit extends to 1 upon log x minus x upon x minus 1. Then applying the limit x as of 1, then log 1 that is 0, then 1 upon 0 that is infinite, again 1 upon 1 minus 1 that is 0, then 1 upon 0 that is infinite, then given indeterminate form which is infinite minus infinite form, then converting to the 0 by 0 or infinite by infinite form with the help of cross multiply and simplified that term, then it becomes x minus 1 minus x into log x upon x minus 1 into log x, that is our 0 by 0 form. Now applying the L'Hopital rule, the derivative of x that is 1 minus derivative of 1 that is 0, here x into log x that is in form of product form. Then applying the product rule, u as it is derivative of v plus v as it is derivative of u, then it becomes x into 1 upon x plus log x. Similarly, in denominator portion again apply the product rule, then it becomes log x plus x minus 1 into 1 upon x. Now simplify that term, then it becomes limit extends to 1 minus log x upon log x plus x minus 1 into 1 upon x. Now here again simplified the in denominator portion x, then taking LCM, then it becomes minus x log x upon x log x plus x minus 1. Now whether check the which form will satisfy, obviously here 0 by 0 form, then applying the L'Hopital rule, then it becomes minus log x minus 1 upon log x plus 1 plus 1. Now applying the limit x as of 1, then minus 1 divided by 2, means that is our finite answer. Now let's see one more example. Limit extends to 0, 1 upon x square minus 1 upon sine square x. Firstly, which form will satisfy? Then here infinite minus infinite form. Then we cannot go for L'Hopital rule. Then simplify that term with the help of cross multiply. Then it becomes sine square x minus x square upon x square into sine square x. Here denominator portion has a sine square x, that is in form of product form. Then in denominator portion we have to apply suppose product rule, then our sum become very lengthy. Then simplification for that, multiply and divide with x square only denominator portion, then it becomes limit extends to 0 sin x by x that is 1, then our term becomes limit extends to 0 sin square x minus x square upon x raised to 4. Now whether check the given form of 0 by 0 or not, then obviously it is 0 by 0 form. Then simplified it with the help of L'Hopital rule, then it becomes 2 sin x into cos x minus 2x upon 4x cube. You all are aware about the basic trigonometric formula, 2 sin theta into cos theta equal to sin 2 theta, then it becomes sin 2x minus 2x upon 4x cube. Again that is 0 by 0 form, then applying again L'Hopital rule, then it becomes 2 cos 2x minus 2 upon 12x square. Again that is 0 by 0 form. Then applying the L'Hopital rule, then it becomes limit x tends to 0 minus 4 sin 2x by 24x. Again that is 0 by 0 form. Then again applying the L'Hopital rule, limit x tends to 0 minus 8 cos 2x by 24. Here denominator portion that is finite value. Then applying the limit x as a 0. You all are aware about the value of cos 0, that is 1. Then minus 8 by 24. Then 8 3s are, that is 24. Then our limit becomes minus 1 by 3. Now let's see the next form, which is 1 raised to infinite, 0 raised to infinite, 0 raised to 0 form. That is our exponential form. Let's see working rule to the evaluating the exponential form. Here our form, which is in form of function raised to g of x, means limit x tends to a, f of x raised to g of x. That means we have to consider firstly whatever the limit, that is our L, and f of x which is greater than 0. Then we cannot go for directly. Then taking logarithm both sides, then log L equal to log of limit x tends to a, f of x raised to g of x. Here log, that is our continuous function, then interchanging the position of limit and log, then it becomes limit x tends to a, log of f of x raised to g of x. Then according to the properties of logarithm, g of x which is comes out, then limit x tends to a, g of x into log of f of x, that is our 0 into infinity form or infinity into 0 form. Then converting to the same as above methods, 0 into infinite, and solving this simplified that term, and our RHS portions becomes any finite value. That means log L equal to k. Now taking anti-log both sides, then it becomes L equal to e raised to k. Let's see the one example. Prove that limit x tends to 0, inside the bracket a raised to x plus b raised to x plus c raised to x divided by 3 whole raised to 1 upon 3x equal to abc raised to 1 by 9. Firstly, which form of it satisfy? That obviously 1 raised to infinite. How? Then applying the x as a 0 to the limit, then a raised to 0 obviously 1, anything raised to 0 that is 1, then a raised to 0 plus b raised to 0, c raised to 0, that these all are the 1, then 1 plus 1 plus 1, that is 3, 3 by 3, that is 1. Now 1 upon 3x, then 1 upon 0, that is infinite, then we can say that that is 1 raised to infinite form. Then whatever the equation which is given, that is that limit, that is our L, then we can write L equal to limit x tends to 0, a raised to x plus b raised to x plus c raised to x divided by 3 whole raised to 1 upon 3x. Now in form of exponential form, firstly we have to taking logarithm on both sides, then log L equal to log of limit x tends to 0, inside the bracket a raised to x plus b raised to x plus c raised to x divided by 3 raised to 1 by 3x. Here our log, that is continuous function, then interchanging the limit and log, then it becomes limit x tends to 0, log of a raised to x plus b raised to x plus c raised to x divided by 3 inside the outside the bracket or raised to 1 by 3x. Now according to the properties of logarithm, 1 by 3x that is comes out, then it's become 1 by 3x into log of a raised to x plus b raised to x plus c raised to x divided by 3, that is our 0 into infinite form. Now simplified that term means converting to the 0 by 0 or infinity by infinity form. Then limit x tends to 0, log of inside the bracket a raised to x plus b raised to x plus c raised to x divided by 3 divided by 3 raised to x. Obviously that is 0 by 0 form. Now applying the L'Hopital rule, then derivative of log x, that is 1 upon x, means we can write 3 upon a raised to x plus b raised to x plus c raised to x inside the bracket a raised to x log a plus b raised to x log b plus c raised to x log c divided by 3 divided by whole divided by 3. Now simplify that term and applying the limit x as a 0, then anything raised to 0, 1, then a raised to 0 plus b raised to 0 plus c raised to 0, that is 1 plus 1 plus 1, that is 1 by 3. Inside the bracket a raised to 0 log a plus b raised to 0 log b plus c raised to 0 log c divided by 3. Then 3 into 3, that is 9. Then we can write 1 by 9 log a plus log b plus log c. Then according to the properties of logarithm, log x plus y, log x plus log y equal to log x into y. Similarly, here we can write 1 by 9 log abc. Now according to the properties of logarithm, means we can write log of abc raised to 1 by 9. Now taking logarithm both sides, then L equal to abc raised to 1 by 9. Now let's see the one more example. Limit x tends to 0, 1 upon x raised to 10x. Here L equal to limit x tends to 0, 1 upon x raised to 10x. That is our infinity raised to 0 form. Then taking logarithm both sides, because that is in form of exponential form. Then limit x tends to 0, log of 1 upon x raised to 10x. Here interchanging the position of log and limit, then limit x tends to 0, 10x into log of 1 upon x. That is our 0 into infinity form. Then converting that form in form of 0 by 0 or infinity by infinity form. Then it becomes limit x tends to 0 minus log x upon cot x. Then applying the L'Hopital rule, then it becomes minus 1 upon x upon minus cos x square x. Here simplified that term, then it becomes minus minus sign which is cancel out. Cosec x, that is we can write 1 upon sin x and simplify that term. Then it becomes limit x tends to 0 sin square x upon x. Here multiplying and divide with x in denominator portion, then we can write limit x tends to 0 sin x by x, that is 1. Then limit x tends to 0 sin x by x whole square into x, then we can write 1 into 0, that is 0. Now log L equal to 0, then taking antilog both sides, then L equal to e raised to 0. Obviously anything raised to 0, that is 1. Now let's see the one more example. Limit x tends to 1, 1 minus x square raised to 1 upon log of 1 minus x. Here capital L equal to limit x tends to 1, 1 minus x square, 1 upon log of 1 minus x, that is in form of 0 raised to 0 form. Then that is in form of exponential form. Then obviously taking logarithm of both sides, log L equal to limit x tends to 1 log of 1 minus x square raised to 1 upon log of 1 minus x. Here simplified that term, then it becomes in form of 0 into infinite form. Now converting to the 0 into infinite form into 0 by 0 or infinite by infinite form, means simplified that term, then it becomes limit x tends to 1 log of 1 minus x square upon log of 1 minus x. That is our infinite by infinite form. If it is infinite by infinite or 0 by 0 form, then and then we have to apply L'Hopital rule. Now applying the L'Hopital rule, then limit x tends to 1 minus 2x by 1 minus x square whole divided by minus 1 upon 1 minus x square. Now simplified that particular term, then it becomes 2x inside the bracket 1 minus x upon 1 minus x square. Here in denominator portion 1 minus x square. Then expanded term means a square minus b square. Then a minus b, a plus b. Then a 1 minus x which is cancel out. The remaining term becomes limit x tends to 1, 2x upon 1 plus x. Here denominator portion has a finite value or a does not 0. Then applying the limit directly, then it becomes 2 by 2, 2 which is cancel out, then log L equal to 1. Now taking antilog both sides, then L equal to e raised to 1, which is our finite or normal value of e, that is 2.718. Let's see that these all are the practice example. Try yourself. I hope you guys, you all are learned something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do this, share with them. If you watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this topic, then feel free contact me. Thank you so much for watching me.